Bismillahirrahmanirrahim. Assalamu alaikum. Today we're going to look at a new section of this topic, and it is a functional group that you have met briefly, but we're now going to look into a little bit more details. So amides, as some of you may call it, a peptide bond, is made up of C110, and sometimes they call it NH2, but as long as you see this C110 bonded to a single bond N, then that's already an amide bond. Okay. Why I don't call it NH2? Because it can be an alkyl group, it can be H, it can be a methyl group, it can be an ethyl group, and etc. And on the other side, on the left side of the molecule, it can be any alkyl group which is used, which is represented by the R. Okay. So CONH2 is the functional group of an amide. Amide is derived from the carboxylic acid. Okay, so you have already looked at the production or the formation of amide based on the combination of ammonia or amine with acyl chloride. Okay, here they say carboxylic acid, but we know that acyl chloride is the more reactive version of a carboxylic acid. Naming amides, the name end with amide, and then the prefix depends on the number of carbons. So if you have one carbon, it will be methanamide. Okay, and then if it is 2 carbon, it's ethanamide. 3 carbon, propanamide, butanamide, and etc. Okay. Here are some examples of amide. To first and foremost, I want you to be able to spot out the amide bond C110N. Okay, so you name the amide bond exactly as how you would count the normal number of carbons. So you have 2 carbon here, we call it ethanamide. Here you have 1, 2, 3, 4 carbons, we call it butanamide. Okay, the physical properties of amides. You may think that, oh, amides contain NH2. So you would imagine that this N has a lone pair of electrons. Yeah, that nitrogen has a lone pair of electrons, really, but it doesn't behave like an amine. Okay, so amides have relatively highly melting points due to the intermolecular hydrogen bonding. So if you look at one of the nitrogen hydrogen bond, that hydrogen is attached to the nitrogen, therefore that hydrogen will develop a slightly positive charge, because when hydrogen is bonded to FO and N, you will get a polar bond. Okay, so this diagram is showing you the hydrogen bond. Usually the hydrogen bond is between the positive hydrogen and the lone pair of the other electronegative element. So the one in yellow is your correct version of hydrogen bond. So there's the delta plus on the hydrogen, and there's a lone pair on the oxygen. Okay, be reminded that the hydrogen on the carbon, CH3, is not polarized. Okay, it doesn't have a slightly positive charge, therefore it will not be attracted to the lone pair on oxygen. Okay, now, so amides can form hydrogen bonding between itself, between one molecule of amide and another molecule of amide. That means it can also form hydrogen bonding with water. Okay, when it can form hydrogen bond with water, we say that it is soluble in water. Okay, however, the solubility decreases with increasing carbon number. Now, if we just look at this, so it is the C double bond ONH2. CONH2 is the polar part of the molecule. Sometimes it's called polar head. And then the hydrocarbon tail is called the non-polar hydrocarbon tail. So you can imagine hydrocarbon tail between ethanamide and butanamide, uh, ethanamide is more soluble in water because the nonpolar part of the molecule does not dominate. Okay, in butanamide, you can see that the hydrocarbon, the carbon hydrogen bonds are much bigger and longer than the polar C double bond O NH2 part of the molecule. That means the nonpolar hydrocarbon tail will dominate. Okay. Recognize that amides are neutral. Okay, now if this was an amine or ammonia, you would imagine, oh, that nitrogen has a lone pair of electrons, therefore it can attract or it can pick up the H plus. Okay, but please take note that this does not happen. Okay, the reason for that is because of two things. One, the the delocalization is extended. Okay, C double bond O contains a pi bond, so that pi bond is made up of one electron on each p orbital on each carbon. Okay, now another thing that you should take note of as well is that the nitrogen on the hydrogen is actually also sitting in a p orbital, so I draw it here. Okay, okay, so you can see that the purple orbital and the green orbitals, they align with each other, they are parallel to one another. So instead of having the delocalization only concentrated between the C and the double bond O, the delocalization is now extended to the nitrogen as well. So that means you have extended delocalization above and below. The lone pair of the nitrogen doesn't just stick onto the nitrogen, it moves to the carbon and to the oxygen and back and forth. Okay, now the fact that this nitrogen is moving, is delocalized, that means it is not available to attract the H plus. Okay, it doesn't pick up the H plus as effective. So because the lone pair is unavailable, therefore it is not basic. Okay, it doesn't make it an alkali. It is just neutral. We say that amides are neutral. Okay, so that's something that you have to remember. Another argument that they have is because oxygen is a withdrawing atom. Okay, so what happens is the electron from the carbon bond and from the carbon nitrogen bond, even the lone pair of the nitrogen is being pulled away by the oxygen. So the oxygen in a way is like pulling the lone pair electron away. In a way, you know, the lone pair of electron is not available for reaction with H plus as well. Okay, so this is why amide is not an alkali, even though it has the structure and the properties of amine. Okay, because it has a lone pair, so you would imagine it will attract the H plus, but no. Describe the formation of amides from the reaction between NH3 or this is primary amine. Okay, between NH3 and primary amine with RCOCl. Now if you draw your RCOCl, it looks like this and nothing else, no other version. The R1 here means it is an alkyl group. Okay, COCl, even the double bond is not shown there, but you should know that it is C double bond OCl. I've had students writing it as R C single bond O Cl. Okay, the argument is that oxygen has two bonds, you know, it is happy, but that is not how you draw the molecule. Okay, next. Actually, to form an amide, you would need a carboxylic acid, but as I said, acyl chloride is the more reactive version of carboxylic acid, so this is why acyl chloride is used to make amides. Okay, so the general equation for the reaction of aryl chloride with ammonia or primary amine to form amides. Okay, so what happens is that So this is the structure of a RCOCl. Remember that this R group can be an alkyl group, methyl, ethyl, propyl, etc. Okay, so what happens, right? If you look back at topic 19 of your A2, this acyl chloride will undergo a mechanism called addition elimination. Okay, and another name for it is condensation. Condensation is when you start with two molecules to form one product, and in the process you eliminate or you lose something. Okay, in this reaction you see that the HCl is what you release from the reaction. Okay, so what happens is that the nitrogen, the lone pair of the nitrogen, will attack the slightly positive carbon, and then the one of the double bonds of the C double bond O breaks. The C double bond O bond reformed. Okay, and then of course the carbon chlorine bond breaks. Okay, so your product is this. Okay, notice that initially you have 3 hydrogen, but in the product you only have 2 hydrogen. Okay, if you look at your notes at topic 19, you may know what happened to that topic. Sorry, you will know what happens to the hydrogen. Okay, right, the new bond that you are forming is this C single bond N. Okay, and also the easiest way to spot out that you only need 2 hydrogen instead of 3 hydrogen that you started with, NH3, count the number of bonds around the nitrogen. Okay, you have this CN bond, which is you just form, second bond with NH, and the third bond with NH, and you are done. You are sorted. We want a neutral product. Okay, don't try to add another one, because if you have 3 hydrogen, then this molecule becomes positively charged. Okay, which is your quaternary amine. Okay, the next one is showing you the reaction of an acyl chloride with a primary amine. Okay, so R1 over there again is your alkyl group. This time you don't have 3 hydrogen, you have 2 hydrogen instead, but one of the hydrogen is substituted by an alkyl group. We write it as R1. Okay, so again, same mechanism. The lone pair of the nitrogen will attract the slightly positive carbon. One of the double bond breaks. The double bond then reforms, and then it releases the chlorine in terms of chloride, Cl minus. Okay, so what happens? The Cl minus will combine with one of the hydrogen. Okay, and then you form HCl. That is the side product that you are eliminating. But when we look at the product, you see that C single bond N is a new product form. Okay, and you still have your R1, right? R1 will still be there. Hydrogen, and there's 1 hydrogen instead of having 2 hydrogen. Okay, so this is a specific example. That is if you want to form ethanamide. Okay, so forming ethanamide means you have 2 carbons. So the easiest one is to choose an acyl chloride with 2 carbon, and we name them ethanoyl chloride. Okay, so you react it with ammonia, and then you will get that product, CH3COCl. If you cannot see this carefully, I suggest you, CH3, to draw it out. Okay, to draw it out, C double bond O N H2. Right? Okay, the other side product HCl will appear as fume, as a gas. Okay, it appears as steamy white fumes. So this is the structure shown to you already. The new bond form is the C single bond O, as you would expect. If there is an excess ammonia exists, it will react with the HCl form, this one. Okay, if you have a lot of ammonia in excess, it will react with your side product to form ammonium salt. Okay, because ammonia is a base, HCl is an acid, so they can have some sort of reaction. Okay, the second one is producing this particular ethanamide. So I'm going to draw it out just so that you can see it clearly. C3H7, I'm just going to do like that, plus C2H5. Okay, so there are two hydrogen on this nitrogen, and there's one lone pair. As usual, the lone pair will attack the carbon. Carbon will lose its electrons to the original, and the carbon chlorine breaks when the carbon oxygen bond wanted to be reformed. Okay, so what happens is that your new attachment is CH3, C double bond O, CO. Okay. What am I doing here? Sorry. CN. Okay. And but remember, you have a C2H5, C3H5. Oh, C2s. Really sorry about that. C2H5, and there's only one more slot to be around nitrogen, and that slot is taken by the hydrogen. Okay, so we call this C. The general name for this reaction is the formation of N-substituted amide. Okay, the way to name this molecule, first we start with writing down N dash. Okay, we want to look at what substituent is sitting on the nitrogen. So there's hydrogen, we ignore that, and there's an ethyl group. So we call this name, we name this this creature as N-ethyl. Okay, so that's done. Then we go back to the right side. Okay, we count how many number of carbons we have. 1, C3, 4. Okay, so there are 4 carbons, so it should be butanamide. Okay, so same thing. If there is an excess of amine, the amine, if there is an excess of the amine, this amine, which is a base, can react with the other side product, which is a gas. Okay, hydrogen chloride gas, and the equation is C2H5NH2. Yeah. Okay, so this equation can be shown to you how excess ammonia react with HCl. Okay, next one is the formation of N-phenyl ethanamide. So again, you will eliminate this HCl, you form a new bond at the CN bond. Don't forget, whatever is in the benzene ring, you just copy everything else down. Okay, this one, the observation is the same. You will get steamy white fumes. Now product, we start at the nitrogen first. Nitrogen has a hydrogen, okay, and a benzene ring or an aryl ring. Okay, so we call that N-phenyl. Okay, and then on the left we have 2 carbons, so it's N-phenyl ethanamide, and your side product is HCl. Okay, this is nothing new, everything is in topic 19. Naming and substituted amides. I've already mentioned you, the letter N is used to name whoever or whatever is sitting on the nitrogen. Okay, what if you have 2 alkyl group sitting on the nitrogen. So we call this an NN diethyl butanamide. So I'm going to draw how a diethyl butanamide looks like. So butanamide means there are 4 bonds, 1, 2, 3, 4. Okay, and then you have an N, and it says diethyl butanamide. NN means there are 2 substituent. Okay, so it's ethyl and then ethyl. Okay, so maybe I should make up easy one, CH3, CH3, CH3. Okay, so because there are 2 constituents sitting on nitrogen, the N has to be repeated. Okay, it doesn't mean that there are 2 N, but it means that on the N there are diethyl. Okay, so 2 ethyl sitting on the N. Okay, write down the equation. I'll leave you to do that yourself. Now I want to move on to the reaction of amides. Okay, describe the reduction of amides with lithium aluminium hydride. This is something that is not new to you as well. This is the reaction that we looked at in this topic on how to produce amines. Okay, amides can be reduced to either primary amines by reaction with lithium tetrahydroaluminate. Okay, lithium aluminum hydride, LiAlH4. You don't have to worry about memorizing the name. Okay, the solvent is dry ether, and at room temperature, because it's already a strong reducing agent. Okay, so the initial reaction is followed by treatment with dilute acids such as dilute sulfuric acid or hydrochloric acid. Okay, so that's just extra. Now this is an example of an reduction of amides with lithium aluminium hydride. What happens? It just literally change all the atoms in the not really all the atoms of the double bond. Okay, so if I want to add hydrogen, I'll use maybe a green color. Okay, for H plus is just to balance actually. Okay, so CH3 is in the original, CH is also in the original, and NH2. Okay, so you can see that the carbon is just adding, it's just adding hydrogen. Okay, hey, sorry, there shouldn't be a hydrogen here, too much hydrogen. Okay, so that means the hydrogen is being added here. Okay, so no specific heating for that. It can happen at room temperature. The next one is describe amides hydrolysis. So this is something similar to ester hydrolysis, acid or alkali. Okay, both of them have its own advantages and disadvantages depending on what you want to collect. Okay, now with esters, you are breaking down esters into carboxylic acids and alcohol. Okay, for amides, you're breaking it down into carboxylic acids and amine. Okay, carboxylic acid is an acid, amine is a base. So you will see something interesting happening or going on. Okay, so describe amides hydrolysis on treatment with aqueous, alkali, or acid. Okay, so the first example is showing you the acid hydrolysis. It just means that you need aqueous, you need water, you need the this is oxidizing agent. No. Okay, so you just need water and a catalyst. Okay, catalyst can be sulfuric acid or hydrochloric acid. Okay, and the condition is reflux. So what happens? You will break the bond where you just newly met. Okay, if you want to make the amide bond, you connect it between the carbon of the carbonyl and as well as the nitrogen of the amides. Okay, but when you want to form amide, you will start with acyl chloride. Okay, but when you break down the esters, you do not get a an acyl chloride, but you will get a carboxylic acid instead. Okay. Right, so what happens, you break this down. There are two things. Okay. One side will give you the carboxylic acid side, so I'll draw that, and the other side will give you the amine side. Okay. And H, so one more is hydrogen. Okay, so you're actually hydrogen is being added. Okay, so that's why you get CH3COOH, ethanoic acid, NH4 plus. Now I have to ask, why is there an NH4 plus? Because you see, you produce ammonia. Ammonia is in the solution or in the reaction, and there is an acid. Okay, there is an acid in the reaction, which is the catalyst H plus. So what happens, ammonia as a base will pick up the acid to become NH4 plus. This happens to any amine that you use, whether it's ammonia, primary or secondary amine. Okay, if it is an amine, they will have an interaction with an acid. If it is an acid, they will have interaction with a base. Next one is alkaline hydrolysis. So there are two steps. The first one is you use sodium, aqueous sodium hydroxide, and aqueous sodium hydroxide is the catalyst for the hydrolysis. Okay, so what happens, sodium hydroxide will also break at the same bond, because that's the bond that you form when you combine acyl chloride with amine. Okay, so you break down the C single bond N. One side you will get the carboxylic acid, which is the ethanoic acid, and the other side you're supposed to get amine. Okay, I know you only have NH2, but there's also another sorry, not nitrogen, hydrogen. Okay, because otherwise it will not be complete. Single bond. Okay, right, so you get a carboxylic acid and an ammonia, but why do you get sodium ethanoate? Okay, this is because the carboxylic acid that you form initially will straight away react with base. Sodium hydroxide is a base. Okay, so you can see that my acid that I formed will immediately be converted into a salt, because acid plus base, you get a salt. The salt is a sodium ethanoate salt. Okay, so this can be sodium carboxylate salt, as long as you draw the right starting materials. Okay, now, so if I get sodium ethanoate, but I want to collect the acid, there's an additional step. Okay, if you have a quaternary ion, which is sorry, not quaternary. When you have an ionic salt, and then you want to convert it to a COOH, what do? You just need this ethanoate ion to pick up H plus. Okay, so that is why the second part of this reaction is adding the ionic salt onto the H plus, so you get CH3COOH. Okay, and Na plus, but Na plus is it will just be floating in the solution. It will not affect our reaction. Okay, so please bear in mind, you have two choices if you want to break down the amides. You can choose acid hydrolysis, or you can choose alkaline hydrolysis, depending on what your target product is. If you use alkaline hydrolysis, you will get a sodium ethanoate, but you can also get the ethanoic acid originally by reacting with reacting the sodium ethanoate ion with acid. Okay, and that goes in the second step. You do not add sodium hydroxide and acid all in one go, otherwise they will just neutralize, then nothing would happen to this reaction. Okay, the other condition that you need is reflux. Okay, Now, amide and ammonium salt, okay, so they are just saying that you can use a sodium hydroxide to differentiate between these two. Ammonium salt can be NH4 plus. Okay, so I'll just use the simplest. Okay, there's a positive charge. So how do you differentiate an amide? This is amide and ammonium ion, because both of them react with sodium hydroxide, but there's a difference. Okay, for amide, if you want to form amine by breaking that bond, you need to heat it up, reflux. Okay, now for ammonium ion, if you want to give out the ammonia, okay, so what you have to do is just, since you know ammonia is a conjugate acid, you just add sodium hydroxide to it with no heating. Okay, so one uses heat, the other one doesn't use heat, but they will give you the same product, which is ammonia. Okay. Okay, the last part, basically it's the same thing, hydrolysis of an unsubstituted amides, but this time they just want to show that the nitrogen is only attached to one hydrogen and the other hydrogen is substituted by an alkyl group. And this R1, R2, I don't want you to get confused. Okay, it's better that if you draw it out, C double bond O, R1 and HR2. Okay, because sometimes students can get confused that R2 means this. No, okay, that's not it. So oops, if I just draw it out like that, R is a general symbol for an alkyl group. Okay, so if we look at the acid hydrolysis first, okay, so I'll use a different color. Acid hydrolysis, H plus. Okay, you break the C single bond end, you will get R, C double bond O, the carboxylic acid part, plus the amine part, NH2. Okay, so you get the hydrogen that you know, initially you have one hydrogen, now you have two hydrogen. However, this amine, this primary amine, is a base. Okay, so it is basic and it can react with this hydrogen. Okay, this base and this hydrogen can react with each other. Okay, so you will get NH3 R2 plus. Okay, that's your hydrolysis with acid. The other one is hydrolysis with base. Same thing, you're breaking the same bond, except that you now have C double bond O, R1, OH, okay, that's your carboxylic acid, and your amine, NHR, but you know you have another hydrogen. Now, acid reacts with a base. When acid reacts with the base, this acid, okay, RCOOH, will lose its H plus to form RCOO minus. That H plus combines with the OH minus to form water. Okay, depending on the type of bases that you use. If you use sodium hydroxide, then you will have the counter ion Na plus. Okay, so you get you get what we call not an acid but a salt plus a primary amine. Okay, how do you change the salt to your carboxylic acid? You just add H plus. Okay, but in the later step, because this is a two-step process or reaction. So you have RCOO OH. Okay, easy. That is how you get how you convert your ionic salt to your carboxylic acid. Okay, so basically I've already, these things are just telling you, explaining you what I have shown. Okay, okay, right, so that is all for today. Assalamu alaikum wa rahmatullahi wa barakatuh. Thank you, everyone.